Welcome, everybody. This is the Coldwell Building Envelope Consulting Pushing the Envelope podcast. This is a really cool episode that I'm excited about. We have some guests with us today. I have Kevin Kennedy from Harvard University and Peter Brooks and Mike Cioffi from IR Analyzers. And we're generally going to talk about some non-destructive testing, issues related to how that can help with managing facilities in especially institutional settings, and advances in those areas, and just see where that kind of goes. So that's the idea, and we'll get started. So first, Kevin, would you mind giving us a little intro about yourself?
Sure, absolutely. Thank you for having me on. I appreciate it. I'm with Harvard University. I'm one of the project managers over here. We really specialize in going in and trying to fix up some of these facilities. We deal with brand new facilities all the way to over 300-year-old buildings, and just trying to do best we can to be good stewards of what we have going on at Harvard. My background is I have a degree in architecture and a degree in urban and regional planning, and I've kind of dabbled around, but what I've really realized is that I like to fix up things and try to be a good steward to the future for making sure that a lot of these buildings that we have out there are going to be able to last. And what's the most environmentally friendly and long-term view that we can take for getting these buildings online and running. So I'm excited about this conversation. Thanks for having me.
Fantastic. Thanks, Kevin. And Peter, how about you?
I founded my company 40 years ago, doing non-destructive testing. And of course, we started in infrared and have since branched out into all the different kinds of non-destructive testing for roofing and waterproofing. We're still excited about it. It's a great field. It provides people with a lot of great information. Kevin, it's exciting. Your position is very exciting to me. What a neat job. It's very, very cool. So we can talk about non-destructive testing. Matt, you mentioned potentially working a little bit with AI, and honestly, I would love to hear what you folks are doing with that. We don't do a lot with it, and I can tell you some things we found out trying to use it a bit.
Fantastic.
But we'd love to hear what you're up to.
That sounds great, and I definitely look forward to looping that into the conversation as well. Mike, last we talked, I think, was at the Lobster Bake at IBEC last year. What's new with you, and what do you do at IR Analyzers?
Yes, sir. Yeah, good morning, everybody. My name is Mike Cioffi. I've been working for Peter for 3 years as a senior account manager. And prior to IR Analyzers, I've worked in the commercial insurance space as well as nonprofit. And I enjoy working with contractors, architects, engineers. We love talking about roof moisture survey and electronic leak detection, and very appreciative to be here today.
Cool. Looking forward to it. So I think maybe to get started, Kevin, what are some things about non-destructive testing that are particularly interesting to you as somebody who's managing and trying to care for these buildings? What is it about that technology, generally speaking? We can get into the particular methodologies, but just in general, what is about the NDT non-destructive technology that's particularly appealing?
Yeah, I think that it's a really exciting time right now. We're really breaking through a lot of thresholds that we've never even thought of. I think sometimes, with AI, we're limited sometimes by our imagination of what could be done. To me, if I could get good data on my buildings, I can make a lot better decisions. And if I could send a drone or a robot into a building while nobody's in it, and it can go room to room and show me images within the room, what's going on behind the walls that we can't see, that's going to change. That will just completely change the way I view my building. and, you know, setting up my maintenance plan, my ongoing plans for, you know, capital improvement. If I know, oh, this roof's pretty good right now, but, you know, the lifespan is X, and, you know, we're starting to see some deterioration here or there at the seams. Maybe there's something we could do to hold it over for now, but let's go ahead and put it on the plan for, you know, replacement at this time. That's so much better than somebody coming to me saying, we got a huge leak, we got a huge problem, we got to fix it right now. There's nothing more frustrating to me than just going around putting out fires. So if I can anticipate a fire before it starts, that's just so much better.
That makes a lot of sense. And do you find that, or maybe what do you find about the ways that the industry has tried traditionally to solve that problem that is like less than satisfactory?
Yeah, I mean, it really is based on problems. You know,
Mhm.
we don't know we have a leak until water is already entering the building. So for me, being able to find technologies and methods to be able to find those leaks before they actually enter the building, before they're seen, and before they become destructive, it's so much better.
That makes a lot of sense. Makes a lot of sense. Peter and Mike, how much have you guys been using your techniques and services in that kind of proactive way, where there may not be a problem that somebody knows about? Like, I know often, you know, we get into IR surveys when maybe during construction, for example, the part of the roof gets left open and we suspect that there's some water that got in there, or we know there's a leak. We're trying to understand the extent of that leak, or the roof is old and we suspect that there's probably been some water and we want to know how much of the roof has been impacted. Like those kind of situations where we have a suspicion already that there's a problem and we're trying to understand maybe the extent of it or how serious it is. Aside from that, how often are you guys working in a situation where you're coming into a building that maybe, as far as everybody knows, is okay, and you're trying to identify ahead of time where there might be issues that you could proactively address?
That's such a great question, because in some areas of facility maintenance and support, you know, proactive approaches have long been really, really popular, like electrical testing with infrared. You know, say you get an annual survey, you have much, much reduced chances of having some kind of catastrophic failure. In the roofing industry, you know, in terms of, and in building envelopes too, there's really much more emphasis on reactive approaches. If it ain't broke, don't fix it. Out of sight, out of mind. There's things that go on with roofing that are kind of unique in the building. Sorry, but
no, it's 100% accurate.
You do get a lot of, oh my God, what do I do now? Situations. We do have some customers who approach it proactively. We have one big customer, we test their roofs every 6 months. That's a, you know, pretty intensive program, but certainly there is great potential both with roof moisture surveys and with electronic leak detection to stay ahead of problems, because you have this unique ability to locate these as they're developing. So Kevin, I'm on the same page with you. We are on the same page with you, that's for sure.
That's very interesting to me about the electrical survey you mentioned, because obviously in the, you know, I'm in the building envelope world where we are often dealing reactively with things. Obviously, one of the big things that our firm tries to do is to get on the proactive side. But a lot of our business certainly comes from situations where the problem has already developed and someone is looking for help dealing with that. But I'm not familiar with that, the electrical side that you mentioned, where someone may be doing proactive surveys with infrared or other technologies. Could you talk a little bit more about that? Is that typical in that, you know, part of the building assembly? And maybe Kevin, have you worked with that kind of surveying at all?
Yeah, I mean, I'll let Peter address some of it, but yeah, we've brought in, you know, analysis so we can just get a picture of our circuits, and if we find a hot circuit, we can go in and figure out what's going on. So that's definitely very helpful. That can definitely identify issues before they happen, for sure. But I'd love to hear what Peter has to say about that.
Yeah, it's been a staple really for 50 years. Because electrical problems typically heat up before they fail. You know, if the circuit is running at a certain temperature, it's fine. Once you start to get an anomaly, you have a piece of equipment or a juncture that is overheating, that will keep heating up until it actually catches fire. And so, you know, there's many instances of catastrophic failures in buildings from electrical fires.
Absolutely. And I could guess that may point to one of the reasons why perhaps it has been successful in a proactive way with electrical and not so much with the building enclosure issues. Perhaps it goes to that fear aspect where it's maybe a bit easier for people to justify and understand that kind of proactive approach when the consequence of failure is an electrical fire, which at least to me sounds scarier than a roof leak, even though I do know all of the problems that can come from roof leaks or other building enclosure leaks. Certainly can be just as expensive and you know, potentially as hazardous. But I think to the average person, that probably is a scarier proposition that they could have an electrical fire. Does that make sense to you guys as to perhaps why that one hits and the enclosure proactive approach is not so popular?
Yeah, I think people are afraid of fire more than they are of mold, you know, but
Right.
you know, mold can have a serious effect on our health and our productivity and our desire to go into work. You know, it
Certainly.
really is you know, the slow entry of water into a building is not just destructive, but it also has greater ripple effects as well. If people are in an environment and they see that there's a leak, they report it, but then they're like, why am I working in this environment? This doesn't even feel like a safe environment to me. So that there's a certain amount of being able to satisfy your employees by giving them an environment they feel great about as well. So it's there's many layers to it. I think especially at Harvard, where we have, you know, scientists that are winning, you know, Nobel Prizes and being able to really push the cutting edge on, you know, discovery. We have to give them top class facilities. And if they feel like they're not being provided that, they're going to go somewhere else. And so we want to keep those people here doing their research so that A, they can do amazing things, and B, we want to do it at Harvard.
That's a really interesting point because it illustrates this idea of how the cost, let's say, of these kind of problems, it goes beyond even just the cost to replace that portion of the assembly, maybe even the cost of temporarily relocating some people or some of these things that are a little more obviously related. But say you lose a Nobel Prize winning scientist to another university, that's an extraordinary cost in money and reputation, in attracting students and all kinds of other things that are third, fourth, fifth order effects. That's very interesting. Mike, have you run into any sort of typical objections to you know, this kind of approach when you're talking with potential customers and you know, talking with them about the values of these non-destructive surveys for finding problems before they get to be extraordinarily large?
It really depends on who you're talking to, and my capacity and our approach is very consultative. So we'll talk about the fact that we're a third-party database test. Our only interest is giving folks good insight as to where the problems are and the extent of them. So typically our conversations are education based. We'll tell them what the testing equipment can do, what it can't do. And then if things need to be discussed in a larger fashion, we're always happy to jump in and help facilitate or just speak in those conversations to add our recommendations, if that makes sense.
Yeah, it does. I think now's maybe a good time to talk a little bit, just briefly, on the different technologies or tools that you guys use and what the strengths and drawbacks might be of each of them, if you don't mind.
Started out in roof moisture surveys. And when we started, we were doing something that very few people even knew what it was. So we started out from an educational perspective right from the get-go. We had to tell people what we were doing before they would say, yeah, that sounds like a good idea. Maybe we'll try that. And so we expanded into from infrared into nuclear and capacitance testing. And the biggest changes in those techniques right now are kind of people focusing more on nuclear and capacitance than infrared. Infrared is, of course, always thought of as the go-to for a moisture test, but it's often not the best choice, or it may not be a complete choice. It's also the most finicky test. It's the most subject to false negatives and false positives. Between our technicians on site and our customers coming to us and saying, you know, I'm looking for a different kind of test. We tried infrared, didn't work, or, you know, we like nuclear because of its stability, because of its reliability. So we're doing increasingly more capacitance and nuclear. And also because infrared is so fussy about the conditions, it needs a sunny day, low winds, dry surface. These are getting harder to find. The climate is changing. And nuclear and capacitance are both much less fussy. They don't need certain weather conditions nearly so much. And then, of course, 15 years ago, our customers started coming to us saying, you know, we need electronic leak detection. You folks should supply that to us. And so we looked, and they said things like, you know, this will find a pinhole in a membrane. And I was very skeptical, frankly. But we looked into it and talked to a lot of people who had experience and started buying equipment. Now we've done, you know, many millions of square feet of this and found thousands of pinholes. So it's pretty exciting stuff that can actually pinpoint where the leak is happening. So, and just like there are different reasons to use one type of roof moisture survey over another, there's different reasons to use a certain type of electronic leak detection over another. So we do all the types, and we often, you know, combine them to complement each other on the job site. So that's been kind of exciting. So now we test not just roofing, but waterproofing. So these are big changes in the industry. And sometimes we even combine both leak detection and moisture surveys to give people a complete picture of what the true condition of this assembly is.
What would you say to somebody who doesn't have any understanding really of what moisture detection survey or these kind of, I don't necessarily want to say imaging techniques, but visual based techniques like infrared, like nuclear imaging, what are they trying to accomplish? Like, I think some people may have an idea that it's kind of like an X-ray for the roof or something like that, but that's not it. So explain to someone who's new to this what those techniques are actually doing and what they're trying to accomplish.
Yeah. So the moisture survey techniques are going to isolate areas of moisture damage versus areas that are dry. And there's a lot of advantages to that. It's a good picture of the true condition of the assembly. It can't be developed any other way. You can't do enough core samples on a roof to get a true picture of what's wet and what's dry. And you wouldn't want to anyway. That's what moisture surveys are about. On the other hand, leak detection surveys are about pinpointing holes in the membrane. And for many years, of course, people would say, hey, we got great information from your moisture survey, but where are my leaks happening? And we would have to say, we don't really know for sure. We only know where there's moisture. So it's been very exciting to be able to help people. Sometimes, you know, they might have a 500,000 square foot data center, and we can test it and find 13 holes in the membrane, on a relatively new, high quality thermoplastic membrane. So that's pretty exciting stuff. These people are able to stay ahead of their problems this way.
That makes a lot of sense. It sounds like when you're doing these kind of surveys, these techniques really lend themselves to building up a corpus of data, especially if you're doing it repeatedly at the same property. And I'm working towards talking a little bit more about how AI may play into some of these techniques and methodologies. But how do you guys work with and use this data over time? How do you or do you try to take a quantitative approach to working with this data? I can imagine if you're scanning the same building every 6 months or every year, obviously you can look visually at the drawings that you produce and see perhaps if areas are growing or shrinking, if there's new anomalies or something like that. Do you get into any kind of data analysis from a quantitative perspective?
Well, that's a good question. There's kind of two parts to that. One is when we test for moisture, we consider any moisture in the assembly unwelcome. And so we are fairly fussy about it, even low thresholds of moisture. And when we do a test, it happens fairly often, a year later, we'll go back and test the roof. We can overlay the new findings versus the old, and they are almost certainly going to be different.
And I imagine.
Yeah, I'm sorry.
Go ahead.
No, I don't know if I have too much more to add. You can always do more quantitative analysis of the amount of moisture, like with gravimetric analysis of a core. We honestly don't get a lot of requests for that. Most people say, hey, we got water damage here, we don't have it over there. Now I know kind of what direction I might want to jump, what kind of decision I might want to make.
And Kevin, how do you and your team go about reviewing and analyzing this kind of information over time? Whether it comes from a consultant's assessment survey report, like from us or from IR analyzers, from reports from occupants, or other facilities people on your team. You're getting all of this inbound data, I imagine, in various forms, some anecdotal, some maybe more scientific. Today, how are you managing that and trying to turn that into some actionable plan?
Matt, I really wish we had a great system for doing that. From my perspective, being a project manager, I'm usually brought in to repair something because it broke.
Right.
And so I rely heavily on the facilities managers to provide the anecdotal information and the data that would help me be able to fix that. And I can't say confidently that we have a system in place that is able to curate that in a way where it's actionable. We bring you guys in and say, hey, what are we going to do? Well, let's go talk to all the maintenance guys, and they can tell us where all the known leaks are. Well, that's kind of dealing with what's already kind of broken through the threshold here. What's behind the walls that I'm concerned about as well. So, I think to try to open our minds to figure out how we can look at it from a different perspective. Can we, from inside a room, be able to do some types of scans that can give us some early indicators of leaking that's going on? Is there something that we can do, whether it's through pressurization or, even, air quality analysis of, there's some mold in the air. There's some we're sensing something in here that something's not right. That kind of data would really be helpful to say, okay, we think there's a leak somewhere around here. Because as we see water somewhere, it's coming from somewhere else. It could be on the other side of the building. I mean, that's the real challenge. And to me, it's getting more data, which would be more helpful than just kind of applying band-aids as we go along.
Absolutely. And I think that's a really great transition to start talking a little bit about artificial intelligence and some of the advances in that area and how that might be able to help us here. I'm certainly no expert. I don't claim to be anywhere near one on the topic, but it's an interest of mine, no doubt, and something I've been trying to pay attention to in my spare time over the last, especially couple of years since it has really burst onto the mainstream. Obviously, there's been research in this field going back decades, but it has kind of jumped into the front of everybody's mind as of a couple of years ago when ChatGPT burst onto the scene. And so in general, I am very interested in the forefront of technology, and I'm always kind of an early adopter of stuff. So I've been experimenting with different tools and things like that over these last couple of years. And one thing to me that has actually been useful in that time, as opposed to all the ideas that I have and others have about how it could be useful in the future, which may well come to pass. But in already today, one way that I've found these tools to be extraordinarily useful, and by that, these large language models, is in synthesizing, summarizing, parsing huge amounts of data quickly and in a useful, intelligent way. And so that seems to match very well with what we're talking about here, where I could imagine a scenario where we start collecting a whole lot more data. Great news, Peter. Harvard hires you to scan every one of their roofs twice a year and to walk through all of the buildings and do interior IR scans as well, so we can start identifying some of these anomalies. That's going to produce an extraordinary amount of data that then somebody has to go through and actually decide what's a problem and what's not a problem and how to prioritize and where it all goes, right? So it almost could be unfeasible even if you start getting the data. But I think that's where something like these artificial intelligence tools could really help, because they're able to parse through, and even in visual analysis, not just text, but being able to look at a series of images and help to point out areas that might be concerning, track changes over time. That I could imagine being very powerful even today, even with the technology that exists today.
Yeah, and I think that if we continue to build a database that AI can draw from, it's only going to help us be able to anticipate issues. So if you could have, let's say you have a building, you have the plans scanned in by AI, and they can match that up with similar buildings which have had similar repairs, even the type of building, whether it's concrete, whether it's post and beam, mass masonry, whatever type it is, it might already know what the vulnerabilities are for that type of construction, yes, that type of roof, that age roof. And it could actually probably give you a probability, like, this is probably where you're going to have issues. Look there first. Yes. And Peter probably all knows this. As soon as he walks on, he knows, okay, I bet you the leak's right there. But if AI could do that for you well in advance, I mean, you could just really have a strategic way of going in and saying, well, let's look here first. AI is telling us it's probably going to be right here.
Yeah, the word that you mentioned that really sticks in my head, and I 100% agree with, is probability. Getting to a point where we can make a more statistical analysis of these issues is really where we're driving at in my firm, because we often end up in a situation where we have reviewed a condition and we know that there's a potential problem, there's a risk in the future. We're very good at identifying when there's risk from either some deterioration that is happening or aging or something like that. We know that, okay, at some point in the future, there'll be likely this problem. And we're also very good at identifying a variety of options to address that risk at different price points, different durabilities, right? So there's kind of good, better, best approaches to fix something, and those each cost something different based on the current market conditions. So we have all of that data. What we don't have is a good way to compare and analyze the ROI on those different approaches, right? So we can say, hey, Kevin, like you could patch this area, you could coat over the roof, you could do a roof coating restoration, or you could replace the roof. And these are 3 ways to address it. And we've gotten some feedback from contractors, so we know that the cost today in 2024 is X, Y, and Z dollars for those different approaches. And if by chance you let this go into the future, the cost is probably going to be this much in 2027, and this much in 2030, and this much in 2035. And you say, that's great, but like, how likely is it that I'm going to have to actually have that problem occur and then address it in the future? What if I just let it ride? What are my chances of something happening? Because I need to compare, is it worth spending $50,000, $100,000, $500,000 today versus some unknown risk in the future? And honestly, we don't have a great way of quantitatively analyzing that right now. And I think that is the gap that the industry really should work on. And it seems to me that using AI tools to help pull together all of the data that we have and the data that we can start collecting and drawing those conclusions, that to me seems like the biggest hole that we can fill with this technology right away. So Peter and Mike, have you guys gotten into using drones at all as a platform for your IR surveys? And if so, how's it going? And if not, why not?
Yeah, we use drones occasionally. Really, I mean, we do lots of square footage. So drones would seem like a really logical choice. Most of our customers need greater accuracy than drones typically provide. If you have a really simple roof that scans really well, no matter whether it's a drone or you're on the roof, the drone can give you a good overview of it. But many roofs don't really scan that easily. Infrared on the roof survey gives you so many more opportunities to parse out, well, why am I getting this weird image? You can actually go and touch the material. You can walk on it. You can kick it. You can get down on your hands and knees and find a little hole or find nothing. So the accuracy of an on-the-roof survey is, vastly superior, really. Drones, I think, shine most if you have a campus with many buildings and you can less expensively, not super less expensively, but at least somewhat less expensively, get a sort of a snapshot, a thumbnail view of the potential condition. But we've done drones. People send me a lot of drone surveys. They are not, well, they're often really way off the mark. And I'm like, oh, wow, somebody paid money for this. I'm sorry to be so negative, but
that's interesting. Do you see that as mainly a result of the distance away that the drone has to fly, or maybe the movement of the platform, like the drone? I don't know how stable they can be, or some other reason. What is it that, in your mind, causes that lack of accuracy?
Well, I'm sorry to, kind of blow my own horn, but when you've been doing it 40 years, you have an amount of discrimination that is not available to people who've been doing it for 6 months. Many drone providers have never done on-the-roof surveys. So they're interpreting stuff that I would immediately discount. That's not right. I've been there too many times. I know that's not right. And they're just saying, oh, this area is warmer, therefore it's wet. Not true. So
interesting. So it's more of an analysis issue, perhaps, than a technology issue. Is that right?
I believe so. Yeah, I think the drones can hover very, very stably and give you a very stable image. But all infrared is finicky. You know, if you're not testing something at exactly the right time, you know, it's too early. You're getting warm images that aren't wet. It's too late. You've lost your warm images. It's too windy. You don't see the things you're supposed to see. All of these things affect the validity of any infrared survey. And a lot of drone people never really did much with thermography. And anyway, sorry.
No, it's good information because I am always curious, you know, what drives the results in these different techniques. So that's all helpful and not immediately obvious to somebody who's just looking at websites or something like that. What may result in good data or not as useful data.
And I don't want to make it sound like I'm trying to get rid of Peter's job by turning it into AI or anything. But, what are your thoughts on something like putting, you know, we put these land rovers on the moon or Mars. What if we put an object on a roof, you know, a large roof, and just let it go, kind of like a Roomba, where it goes around and, you know, vacuums your floor over a long period of time? What if you release one of these? It does its scans, it finds an anomaly, it gets in closer, it has a series of tools that can do more analysis and dig deeper into it if something shows up on the scan. It can take, you know, wind readings, temperature readings. It can give you, you know, verify that it was done at the right time. I was up on the roof the other night at the Bauer Labs with somebody doing infrared, you know, scanning, and it was like nighttime. I'm like, is this really when we're doing this? I'm like, yeah, I guess so. So I'm just, it's not the most conducive thing to us, you know, as people trying to stick to a, you know, 6 to 3 or whatever, you know, time period for construction, to be out on a roof at 8 p.m. at night. So I'm just wondering, do you think that there's a future for being able to release the robots and let them do a lot of this analysis for us?
Absolutely. I think it's a big step, but I believe that certainly things will go in that direction. It's just a matter of time before some technology is being, say, crawling the roof. And, you know, everything is moving in the direction of less operator interpretation.
That makes a lot of sense to me. And that's, I think, a really useful thing to think about is what type of, let's say, services or tasks will be most readily done by this emerging technology as it develops. And something like regular ongoing survey of difficult to access, dangerous, complicated access locations, to me seems like a great application for robot technology. Yeah, I was gonna, when Peter was talking about using drones or not for these surveys, one thing that came to my mind was that, you know, one benefit is that it could improve safety. You don't have somebody walking around on a roof in the dark. And, you know, obviously, hopefully those people are experienced and well-trained and they understand the risks and they can take precautions, but still, it's would maybe be better if a person was not walking around on the roof in the dark. If for no other reason than, you know, they'd rather be home watching Netflix. But the opportunity to use robot technology combined with, you know, what essentially is imaging to, you know, gather that kind of data in a safer, potentially less expensive way, that is very interesting. I think especially with some of these humanoid form factors that are getting developed as well. So, you know, my first thought is like, well, you know, my Roomba gets stuck under my couch, or you know, it gets hung up on the dog bed or something like that. There's all kinds of things even just around the house that as good as the Roombas have gotten, they don't always navigate all that well. So if I'm picturing a roof with gas lines running across and penetrations and drains and all kinds of things to get in the way. It's hard enough for a person to walk around up there sometimes, but I think that's one of the benefits and one of the reasons why these companies are pursuing these humanoid form factors, because it eliminates or potentially eliminates a lot of those issues where if a person could walk there, then the robot that moves like a person could also walk there. So I could see that. I could see that down the road.
In the interim, when we do nuclear or capacitance moisture surveys, they can be done during the day.
Right.
But there's a lot of benefits. You're not up there at night. Access is simpler in areas where maybe you're nervous about the neighborhood. You're much more comfortable being there during the day. There's a lot of reasons why, we've had something of a shift to these other, moisture techniques.
That makes sense.
I've seen robots that can break dance better than some of these people at the Olympics. So, I think that we can figure out how to get one move around. And I like the idea of even being able to get into our facilities when they're closed, especially highly securely facilities. It takes so much effort to get somebody into certain rooms and certain spaces just due to, access issues. If we send in a robot, we know they're not going to steal anything. It's a lot easier to accept saying, okay, let's open this clean room so that a robot can go in, and they're not going to bring contaminants of some sort, that maybe a human would. I just like the idea of the possibilities of turning something on, walking away, coming back, pulling the thumb drive, putting in a computer and downloading an entire night's worth of data collection. It just feels like that's an efficient way of getting information.
No, it certainly makes a lot of sense. And on some level, we do that. We've used moisture sensors, temperature, humidity sensors that, log data over time for years now. So, there's a building where we suspect there's a problem with moisture levels, and maybe we think they fluctuate, or we wonder if they fluctuate, if there's certain patterns seasonally or throughout the course of a day or week or month. We'll go and install these sensors and then come back sometime later, collect them, look at the data, plot the data, and see what we see. So it's an extension of that kind of idea. And, that's in contrast to, for example, sending somebody out there once a day, twice a day, 100 times a day, or once a week, or whatever the period may be. Obviously, it gets more expensive the more often somebody has to go. But if you just have this electronic box that sits there collecting the data, and you put it in a spreadsheet, and you send somebody out once at the beginning and once at the end, there's huge advantages there. So I think it's that same sort of idea, and it's just a matter of the technology catching up to be able to provide the data and the access that you're looking for. Well, this has been really fun and interesting. Appreciate you guys taking the time to do this. Is there anything that any of you would like to leave us with before we wrap up?
Well, Kevin, I guess I think it's wonderful what you're doing. A very, very interesting job. What would you say is your number one challenge, especially with an older building? To me, anything in that historic realm is very cool. And what do you find is most interesting or most challenging about some of your wonderful old properties?
Yeah, I mean, it really is embracing the history and trying not to mess with it too much. But I tell you, it's becoming more and more of a challenge. Right now, I'm doing a historic restoration at the Arboretum, and we're replacing some slate roofing. And it's like, the old slate, they say will last 150 years. The new slate we get will only last 40. Like, why is that? The materials that we're dealing with now are different, and what you can get out of them has changed. And so it's very challenging, I think, to try to apply new techniques to old technology, and being able to bridge that is it's like a dilemma that it really is exciting, but it also can be frustrating. So, we as Harvard, we have to maintain the historic nature of our buildings, but we also have to make sure that they're going to be standing 300 years from now again. So it's fun, and that's one reason that I really enjoy being here for sure.
I love that work too, Kevin. Working on preservation projects is one of the most interesting parts of why I even got into this field in the first place. Working on restoring some really important and significant historic buildings drew me into the field and is a passion of mine ongoing. And one interesting thing that is becoming more and more prevalent that I've seen, along with the material changes in terms of the quality and availability, is the same could be said for the labor force that is available to work with them. Finding folks that are skilled and experienced in working with slate, working with sheet metal, even masons to a degree. The skill set is not as widely distributed as it used to be. Even in my time doing this, never mind going back 50, 100, 200 years. So that's something that we're all going to be working with too, and a challenge we're going to have to work through. All right, gentlemen, thank you very much. This has been great. I really appreciate your time, and look forward to a round 2 someday when we are talking about the latest robots up on the roofs and other cool new technologies that I'm sure are not too far off. So thank you again.
Yeah, may AI continue to expand, but may we continue to have jobs as well.
You got it, 100%.
Thanks so much.
Thanks, guys.